Which of the following molecules would you expect to have a dipole moment of 0? So a dipole moment of 0 means a non-polar molecule or completely non-polar. So that means that if you do have any bond dipoles, if you have any polar bonds in your molecule, they are pulling, you have another one that's counteracting it. So you'd have equal bonds, so pulling equally in opposite directions. So if we look at the first structure, we see we have a central carbon atom that is sp3 hybridized. And we do need to look at this. We need to look at the three-dimensional shape. Particularly for this one, it might be really tempting to look at this and say, well, we got carbon-fluorine bonds and one's pulling up and one's pulling down. But if we didn't recognize that this is not actually a planar molecule, we could accidentally come up with the wrong answer. So if this is sp3 hybridized, which it is with those 4 single bonds, that's associated with tetrahedral geometry. So if we want to represent that structure, that means we need to recognize that we have this sort of shape. So we've got 2 bonds in the plane, one going into the plane and one going back away from the plane and one sticking out of the plane. So we have a fluorine and a fluorine and a hydrogen and a hydrogen. And so these are not canceling out. They're only 109 degrees, 0.5 degrees apart roughly. So you actually get a dipole kind of pulling in this direction. So that does not have a dipole moment of 0. This is a polar molecule. So this is polar. All right. And if we look at the second structure, so the bonds that we're considering are these carbon-chlorine bonds. And so we need to, again, look at the overall molecular shape. And this is represented a little bit better by the way it's drawn, because if we look at these 2 carbon atoms, the geometry around both of them, we can see that we have 1, 2, 3 sigma bonds, 1 pi bond. So this carbon atom is sp2 hybridized, as is the other one, because they have similar bonding patterns. And that means that both of those carbon atoms are trigonal planar. Right, so trigonal planar, so flat, right? In a triangle, 120 degree bond angle. So we've actually drawn it that way. So it already looks like what the bond angles are. So we've got a carbon-chlorine bond pulling this way and one pulling this way, but that's not opposite directions. So these are not completely canceling out. So this is still a polar molecule. And finally, if we look at the last structure, this is very similar to what we just looked at. But now we've got a bromine pulling this way and a carbon-bromine bond pulling in the opposite direction. So these 2 are actually going to cancel. So these carbon-bromine bonds cancel. So that means that this has a dipole moment of 0. So only this last structure do we have polar bonds that are pulling equally in opposite directions in order to cancel each other out.